Hi, welcome to MooMooMath. Today we're going to learn how to find areas of triangles using both Heron's theorem and a sine formula. And those are in the cases when you have Heron's you use with the side information, and you use the sine formula when you have a side included angle side. So let's start with Heron's formula. This is the side situation. So if you're given three sides of a triangle and it's not a right triangle, this is one option to find the area. So what you're going to do first is find what we call S. S represents the semi-perimeter. To find the semi-perimeter, we're going to add the three sides, A, B, and C, and then divide it by 2. Thus, it's called the semi-perimeter. So we're going to take 5 plus 6 plus 7, and that adds up to, let's see, 11 plus 7 is 18. And then we're going to take 18 and we're going to divide it by 2, so our semi-perimeter is 9. So using that semi-perimeter as S, so let's label that, that becomes our S value. We're going to plug it into Heron's theorem. Now, Heron's theorem is just the square root of 4 items. The first item is just the value S. So in this case, that's going to be 9. Then S minus A. So I'm going to subtract each side from S. So I'm getting the difference. So S minus A is 5. Then I'm going to take S minus B, which is 6, and S minus C, which is 7. And I'm going to multiply those 4 quantities together, and then I'm going to take the square root. So let's calculate this. So we're going to take the square root of 9 times, well, 9 minus 5 is 4, so that's my first difference. And then 9 minus 6, that's 3. That's my second difference. And then 9 minus 7, that's 2. So let's take the product, and that's 9 times 4 is 36. 36 times 3 is 108, I think, and then multiplied by 2. So let's grab the calculator and just take 9 times 4 times 3 times 2. And that gives us 216. So the area is actually the square root of 216. Now, as an exact value, we can find that. That's going to be, I believe that's 6 times 36, which is 6 root 6 as an exact value. But typically, when we're using our calculator, we go ahead and find the decimal value. So let's take the square root of 216, and that gives us 14.7. So 14.7, and this is an area, so we have to think about the unit measure. So that's going to be meters squared. So it's 14.7 meters squared, which would be 6 root 6 meters squared. So there are the areas as an exact value. Exact values have radicals in them. And of course, we rounded our decimal off, so that is our estimated answer. So that's how you find area with side. Now we're going to look at this area formula for a side angle side situation. And I just call this the sine formula because we are using the sine of the angle. So to find the area, we're just going to take 1/2 BC sine A. So B and C are the 2 adjacent sides, and A is the included angle. Now, I want you to think for a second. If we take this area, you guys have always learned that area is equal to 1/2 the base of the triangle, right? The base times the height. Now, I want to think about how you find the height of a triangle. When you're doing the law of sine, to find the height of the triangle, you're going to take the sine of the angle times the adjacent side. So we call this angle A. We call this side B, and then this opposite side over here is little a. And to find the height, in the last lesson, we took sine A times B. Well, I want you to look in our formula, and you can see we have sine A times B right here. Sine A times B. So that part is actually the height, sine, B times sine A. So what's left in our formula? C is left in the formula. Well, C would be the base of the triangle. So that's our base, C. And then for the formula for the area of a triangle, we just take 1/2 of that product. So you can see actually where this formula is derived from. 1/2 BC sine A is really just 1/2 the height times the base. So just showing you where it's derived from is kind of helpful. Okay, we're going to use the sine formula to find the area of a triangle with two side lengths of 9 and 5.2 and an included angle of 102. So let's draw our picture here. We have an angle of 102. Well, 102 is an obtuse angle, so let's draw it a little bigger here. We got 102. And then we have the adjacent sides of 9, and the other adjacent side is 5.2. And then we've got an opposite side over here. But we're not worried about that opposite side. What we just have to look at is the two adjacent sides and the included angle. Well, we're going to simply just plug it into this area formula. So to find the area, we're going to take 1/2 the two adjacent sides, so 9 times 5.2 times sine of the included angle. Well, the included angle is 102 degrees. And that should give us the area, in this case, square meters. So let's grab our calculator. We're going to take 1/2, which is 0.5, times 9 times 5.2 times the sine of the included angle, which is 102. So the area is 22.9 square meters. It's a very simple formula. You just have to have your side angle side and plug it all in. So it's pretty straightforward. Now, how can we use those two formulas to find the areas of figures? So let's start with a pentagon. Okay, we're going to use the sine formula. So let's write it down so we know what we're working towards. We need to use 1/2 BC sine A. So we need a side angle side in this case. Okay, so if we have a pentagon and we know that the radius is 8, the radius is from the center to the vertex, I can draw a second radius. And what do I know its length is? Well, I know its length is also 8. So these are equal. So basically, I have an isosceles triangle right here with two equal sides. Now, I know the radius is 8, but what is the central angle? Because I can say, I'm going to go ahead and duplicate this so you can see it, and copy and paste. Okay, I know both of these sides are 8. I need the interior angle. Well, we have 360 degrees. We can divide it into 5 equal parts because I have a pentagon. So 360 divided equally into 5 triangles. That gives us an angle that's 72 degrees. So this angle right here is 72 degrees. Well, I don't have to work for my altitude or my apothem any longer. I can just use this formula because I have a side angle side situation. So let's just plug in. The area is going to equal to 1/2 8 times 8 times sine of 72. So let's grab our calculator and figure out what that's going to be. So 0.5 times 8 times 8 times sine of 72 degrees. And using our area formula, we got 30.4. for the area of the triangle. Now, that's the area of a triangle. That's this region right here. Well, how many triangles do we have that are the exact same size? Since this is a pentagon, we're going to have a second, a third, a fourth, and a fifth triangle with the exact same area. So let's take 30.4 and multiply that by 5, and that's going to give us 152 square units. And there's our area. Let's double check that. We said 30.4 times 5, just double checking that my head math is right. Yeah, 152 square units. And that's the area of the pentagon, and that's much easier than trying to find the area using the apothem and working harder. Instead of working harder, working smarter. You guys should know the theme, harder, not smarter. Okay, now let's find the area of a parallelogram, but this time we're going to use Heron's theorem. Now you could use your side angle side, but we're going to attempt to use Heron's theorem with this one. Okay, so what I'm going to do is I'm going to draw a diagonal across my parallelogram. So I've now got a triangle on the bottom left side. I can now find the length of the diagonal using law of sine, or law of cosine. Because let's call this angle A, that means this side is A. And I have a side angle side situation. So to find A using law of cosine, I'm going to take A squared is equal to B squared, which in this case could be 6, plus C squared, which is 10, minus 2 times 6 times 10, all times the cosine of 79. So that will give me the length A. So let's go over here and find that. Okay, I'm going to take 6 squared plus 10 squared, subtract 2 times 6 times 10 cosine 79. And that's a square, that's 113, but remember I have to take the square root of that answer to get the length of the diagonal. So the diagonal is 10.63. So let's make that 10.63 centimeters. Now I've got all 3 sides of this triangle. So I can use Heron's theorem to find the area of this one triangle. So Heron's theorem, I'm going to add the sides. Remember with Heron's theorem, we have to find S first, which is the semi-perimeter. So let's take the 3 sides of 6, 10, and 10.63 and add them up. 10 plus 6 plus 10.63, right? Yep. And get that answer. And then I'm going to divide it by 2 because that's the definition of a semi-perimeter. And we got 13 point, let's use 13.3 just for simplicity. So 13.3 is my value of S. Now I'm going to, in my formula for Heron's formula, I'm going to take S times S minus A. So S, the semi-perimeter, minus A. A is 10.63. Let's calculate that. 13.3 minus 10.63. And that gives me 2.67. And then I'm going to take 13.3 times the next side, which is going to give me 13.3 minus 6 is going to be 6.7. No, 7.3. Sorry, 7.3. And then I'm going to take 13.3 minus 10, and that's 3.3. So let's take the product of those four numbers and take the square root of that for the area. So we're going to take 13.3, or let's go ahead and put our square root in. We'll just do it all in one step. 13.3 times 2, I can't read that, 2.67 times 7.3 times, what was the last one, 3.3? 3.3. And I've already taken the square root, so this will be the area, 29.25. 29.25 square centimeters. So that's how you can use, actually we use two things there. We use the law of cosine to find that diagonal, and then once we found the diagonal, we could find the area of the triangle. Now, is that the area of the parallelogram? No, it's just the area of this triangle. So what do we know about these two triangles? They're the same size. So to find the area of the parallelogram, I'm going to take that and I'm going to multiply it by 2. So let's take that and multiply by 2. And that is going to give me 58.5. So my final answer is 58.5 centimeters squared for the area of the entire parallelogram. So it's kind of cool how you can use the law of sine to find the diagonal and then use Heron's theorem to find the area of the triangle and then double it for the parallelogram. Now let's look at a scenario with an octagon. Okay, an octagon has 8 sides. And then the first scenario, we're going to see how the octagon is inscribed in a circle. That means it's on the inside. If we say circumscribed, it means it's on the outside. But in this case, the octagon is inscribed in a circle, and the circle has a radius of 10. And we need to find the area of the octagon. Well, this one's similar to the Pentagon we did a few minutes ago, because we have this full length, which is the radius of the octagon. It's actually pretty easy. All we have to do is think about the fact that the radius is 10 here, and then we're going to have another radius over here that's also 10. We need to find the central angle, so we can use our side angle side situation. Remember, our side angle side, to find the area, we're going to use the sine formula, and the sine formula is 1/2 BC sine A, where B and C are the adjacent sides to the angle A. Well, this is a octagon. So what are we going to divide 360 by to find the central angle? I hope you said 8. So 360 divided by 8, let's crank that out. 360 divided by 8 is 45. So we have a 45-degree angle as our central angle. So now we can just plug in 10, 10, sine of 45, and we have it. So let's take 0.5 times 10 times 10 times sine of 45, and that gives us the area of a triangle that's 35.35. So that's the area of one of these triangles. But this is an octagon, so how many are we going to have? Of course, we're going to have 8 of those. So let's go back to our calculator and multiply this answer by 8 to get the area of the entire octagon. So the octagon has an area of 282.8. 282.8 square units. And that was a lot easier than the way we did it the other day or last Friday in class. This side angle side formula is much easier, so that's an easy way to find the area of a triangle. So let's look at what would change if we need to find the area of an octagon that's circumscribed about the circle? So in other words, the octagon is now on the outside of a circle. The radius is still 10, but the radius is the radius of a circle. It's not the radius of the octagon. So you have to be careful, because when we're talking about the radius, we're saying the radius of the circle. So what is that? Well, that is actually the radius, the apothem. So the other day we talked about this area. So what we need to do is we need to figure out what the radius is. Okay, and once we figure out the radius, we can then draw it in and then use our formula over here. So we already know this angle is 45 degrees because we just worked an octagon. We've got to work from the apothem back to this longer side, which is the hypotenuse of the right triangle. So that's exactly what I'm going to do. I'm going to work with that right triangle for a second. Oops. Let me flip it around so we can see it a little bit better. Let's just flip it down. Okay, so I'm just taking this triangle right here and I'm basically pulling it out of the figure. Okay, we have a right angle here. We know this length is 10. We know this angle is what? Well, we know the whole angle is 45, so we know that angle is 22.5. It's half of 45. We need the hypotenuse, right? Because that's going to end up being the radius. That's what we need. So what trig function are we going to use when we know this angle is 22.5 and this side is 10? Well, that's going to be cosine, adjacent hypotenuse. So cosine of 22.5 is equal to the adjacent over the hypotenuse. Now, let's solve for that by using trig, so cross multiply. So 10 times 1 is 10 is equal to x times cosine of 22.5. And then divide both sides by cosine of 22.5. So to find that, we're actually going to take 10 divided by that cosine. So let's grab our calculator and take 10 divided by cosine 22.5. And our answer is 10.8. Let's do 10.82 just to make it a little more accurate. 10.82. So that's the length of each of the radius. Well, now this is easy because we have an angle A that's 45 and the two radii are 10.5. So now let's go over here and use our formula again. So when we have a side angle side, we're going to use 1/2 BC sine A, where A is the included angle. So we're going to take 1/2 of 10.82 times 10.82, or you can just take 10.82 and square it, right? Because we're multiplying that times itself, times sine of, and that central angle is 45 degrees. Now be careful. We used the 22.5 because that was half of it to create the right triangle to solve for that radius up there. But in the formula, we're going to use the central angle of 45 because the triangle that we're using to find the area of the octagon is this full one in red up there. So let's grab our calculators. 0.5 times 10.82 quantity squared times sine of 45. And there's our formula all plugged in. Let's see the area. So the area is 41.4. And that gives us the area, remember, of one of these triangles. Well, how many triangles have we got? This is an octagon. So we're going to have to take that value and multiply it by 8. So take that times 8. And our area of the entire octagon is 331.13. So the final answer is 331.18 square units. And there we go. Now you would assume that this one would have a larger area because it's on the outside of the circle than this one that's on the inside of the circle. And sure enough, the first one that had a radius of 10, it was on the inside. The smaller one had an area of 282.8, and the area of the larger one was 331.18. So it is actually significantly larger. So there you go. That's how you find the area of octagons, a simple way to do regular polygons. This works for any regular polygon, so hopefully you'll use it in your homework. So I hope this video was helpful. Thank you for watching the video.